Hi, everyone. Very good morning, good afternoon, good evening, wherever you are, depending on what part of the world. Sorry, I was just setting up my laptop, and that's why I was a little late. Um, just a heads up: the chat on YouTube Live should be disabled, so you might not be able to use it. If you head back to the Eventbrite link, let me see if I can share my screen. Just go back to the Eventbrite link and you should be able to see a help chat link over there, which is uh, tlk.io/PyLadies remote. And I see quite a few of you are already here. I'll join as well. So, is this the first time programming for all of you, or are you familiar with programming and perhaps a different language and just want to get a hang of Python? Okay, someone has a bit of experience in JavaScript and Ruby, first time and learning in Python. That's nice. I'm just still figuring out how to share my screen. And there should be an option here. Oh yeah, got it. My entire screen, yes. Okay, wow, that's not pretty. Let's go to. All right, so is everyone ready? I'm just going to paste the link for this in the chat. I hope you have access to the chat. So, in case you want to follow along with me, uh, this is the slides for the presentation. So, you can access it. Okay. All right, let's get started. So, hi everyone, I'm Grishma and I'm working as a cognitive software engineer with IBM Watson in San Francisco. I work with the data science for marketing team, and cognitive software engineer is basically like a mix between software engineering data scientist. So, I like to think I get the best of both worlds. And I'm trying to get involved with the community for the past year or so, and this is one of the activities. Yep, I hope you're all excited and you all get something out of this session today. And don't worry if I'm not able to answer your questions on chat because I see a lot of messages and it might not be easy for me to keep switching between tabs. But definitely feel free to reach out to me. This is my website. You can contact me using Twitter, LinkedIn, email, whichever method is most convenient for you. And I'll be sure to answer your question if I didn't already cover that in the session. All right, so let's start. Meanwhile, you can just familiarize yourself with Trinket. So you can sign up for a free account. It's not necessary, but I would advise it because it helps you arrange all your folders and files properly and you can access them later. So would suggest you to sign up for an account. Again, it's not required. You will still be able to access the code samples and the templates even without it. All right, let's start. So gone are the days when Python would mean this, right? A snake, danger, panic. And now it probably means a bunch of code, web applications, natural language processing, or just some exciting, magical stuff. So today we'll delve deeper into what exactly is Python like. This is the agenda for today. We'll start with an introduction. We'll go over the environment that we use to write Python in. uh, what is the syntax, what is the grammar of the language, what are different structures in the language like variables, data types, input output modules, what are the different operators we use, how does the control flow in a program, that is what control flow structures will tell us about, what are data structures, and then if time permits we'll cover functions and classes. Even if I'm not able to cover that in this today's session, I still have the slides in this presentation, so you can always feel free to refer to it afterwards, and reach out to me if you have any questions. And we'll finally be concluding with seeing examples of where Python is used in the real world, and then I'll be pointing you out to some handy resources so you can continue learning. All right, introduction. Python is a high level programming language, which basically means that if you look at the structure of the language, it is closer to what humans would understand. It is a little similar to English in the sense there are some keywords that have been picked up from the English language. And it's not a low level. So the other end of the spectrum would be a low level language that is very close to what the machine understands in binary format. It's very readable. It's interpreted, which basically means there are two types of languages. So you have interpreted, which means that you don't really need an intermediate file format. We'll just see it. We'll see it later. This is more, a little above the scope of today's session, so I'll just leave it aside for now. Dynamically typed means for certain programming languages, you have a data type associated with it, which we'll delve into deeper. But just a very brief overview is that data types are what tells you about the type or the structure of the of whatever you're using. So it could be text, it could be numbers. So in some other programming languages, you have to specify if I'm going to use a number now or I'm going to use maybe letters now. But in Python, you don't really need to specify that because it's dynamically typed. All the files that you create with Python code would have a .py extension. And this is the key resource for the official documentation for Python. So I would highly recommend you to go ahead and look at that documentation, familiarize yourself with different rules, different standards that are used, and they also have a great deal of resources on what functions, what things you're supposed to use. Yeah, it's a little difficult. I'm probably going to end up speaking a lot of technical jargon, so I'll try to avoid that. What's an IDE? So an IDE is basically like a notebook, but an online or a virtual notebook which you use to write your code in. It's a software application, it's a development tool, and that's where you actually write your code and then you can test it out if it's working the way you expect it to, or if it's giving some sort of errors. So just think of it as a notebook in which you can figure out what exactly you want to write, how you want to do it, and which is what we'll be using. But today we'll just be using an online editor which is called Trinket, which I mentioned right now. This is basically because we want to save ourselves the headache of setting up the environment. Okay, and some of the popular ones are PyCharm, Spider. You might have heard of some of these. Jupyter Notebook, which is pretty commonly used in the data science world. And like I said, we'll be using the online editor to bypass installing software. So we can all just go to this link. This is what it looks like. You can sign up for an account. This is what is an IDE for us, or an integrated development environment. Okay. Unfortunately, this IDE right now, so there are two versions of Python, Python 2.7 and Python 3. Python 3 is the latest one, but uh, Python 2.7 has been around for a while and a lot of systems use it. So not everybody has migrated to Python 3. So Trinket by default has Python 2.7, but we'll be using this command at the start of all of our code. Oops. To ensure that it ends up using Python 3 syntax. And today's session will be using Python 3 syntax. Okay, coming to the syntax, or in another term, it's just the grammar of a language. It is the rules you use to write code. So Python follows a line-based structure, which means that every line that you see over here is a different command or a different execution. There is something called comments, which is what would start with hashtag, and you use it to make a comment. So those are lines that wouldn't get executed. Usually, you use comments to write more details about what exactly that part of the code is doing, so that if someone else were to read your code, that person could understand what exactly is happening. Or many times, you might not get back to your code till maybe a few weeks or a few months later, and you might just forget, okay, did I really write this code? What exactly happened here? And that's why it's said that a well documented or a well commented code is usually a good sign. And I would highly suggest all of you to use those comments. Uh, in the next few slides, we'll be using some of the templates where I've used comments to write out what exactly that part of the code should be doing. And hopefully that'll be helpful in writing the code. Another interesting thing about Python is that indentation matters a lot. As you can see over here, there's different indentations. So this is like one block which has multiple blocks in it. And indentation just helps to separate blocks, which means that this part of the code would be related to this part of the code. It's a little complex in trying to explain it right now, but once we actually start using it, I'm sure you will get a better understanding. But I just like to highlight, if you're getting some sort of errors or some sort of something unexpected is happening, I would suggest to check the indentation first and see if that is what is expected. So you can see that this would print I am a funny and silly block used in example. And then after that, it would print I am a dull and serious block used in example. So this part and this part, the first and the last blocks would get printed nevertheless. But depending on what iteration or what number it is, so just think of this as running 10 times. So if it's running for the first time, it would go in one of these. So this is for the even numbers and this is for the odd numbers, but we'll get into that later. All right. So before we start programming, we have to. Okay, I just want to cross check. Everyone can hear me, right? I hope I'm, because it'll sound that I'm blabbing to myself, but I can see all of you in the chat. Okay. All right. Okay. Can someone just write that they can hear me, just so that I know it's all fine? Okay, one sec. Let's cross checking. I'm still sharing my screen. Yep. Okay, there are 57 viewers. All right. Yep. Okay, everyone can hear me. Thank you so much. All right, going back. So, this kind of information might be a little redundant with people who have some programming experience. So, please bear with me. For the first 10 to 15 minutes, just think of it as a revision, even if you already know this. This is for the people who don't have much of a programming background. So before we start writing our code, we have to learn what exactly are variables. Just think of variables as a container to store your impression, to store your information, and you can manipulate them. So, for instance, a very simple example of a variable would be name. So the name of the variable is name, and the value of the variable is Grishma. Okay, just think of it that way. Like, it's an object or it's some instance to which you're giving a label. So that label would be called the variable name. Python follows some standards for naming variables, which is that it has to be unique. If it's not unique, then the program will get confused into what exactly which which object are you referring to, or which variable are you referring to. It can only start with letters. It can only have alphabets and numbers, so it's alphanumeric. And it's case sensitive, which means that capital VA, small AR is different from all caps VAR, which is different from all small letters VAR. So all of these are different variables, so it's case sensitive. Just keep that in mind. And there are some special keywords reserved in Python, which mean something very special. So you cannot use them as variable names. Some of the keywords are and, try, if, else. And if you're not sure if the variable you're using is a keyword or not, you can go and type this import keyword and then check if this is a keyword or not. I believe this wouldn't work in Trinket, but if you do have Python installed in your computer, in your terminal, all Mac OSs have it by default, I believe. So you should be able to check that. But let's not think about that right now. Oops. Okay. And funnily enough, there was a survey conducted where programmers were asked what is the hardest task of programming. And almost half of them said that naming things or naming variables is what is one of the hardest tasks of a programmer. So when you start writing a long code, you would kind of get a little unimaginative, or there'd be a lack of creativity in trying to name things because you might just want to name everything the same thing. Like, I have a coworker who loves naming all his variables taco, and after that he just gets out of ideas to name variables. Okay, coming to data types, like I mentioned before, you have to know what exactly is the value inside a variable. Is it a string? Is it a number? So that's where data types help us. There are these three different types, main types of data types, which would be, first one is numbers, where you have two categories. One would be int or integers, which is our numbers, integers like -1, basically the numbers without decimal points. And the numbers with decimal points would be called floats. The second category of data type is called Boolean, which is also bool, and it can take up only two values. So it's a binary data type that can either take up true or false. Like I mentioned, Python is case sensitive, so just be sure that the T and the F are capital whenever you start using this data type. The third one, and probably the most common one, is letters or words, which in Python or in most other programming languages are called strings. And the way to use strings as you denote them using quotes. So you can either use double quotation marks or you can use single quotation marks. And if you're not sure what exactly, like I mentioned before, Python is dynamically typed, which means that you won't really know what exactly is the data type of a variable when you specify it. So you can just use type of A, where A is a variable. 1452 is the type of it, is the value in the variable. And it tells you that it is of the type class int, which is integers, which is an integer. This is a funny meme, which basically says, what did the Boolean say to the integer? You can't handle the truth because Boolean can take up true and false values, and integers cannot do that. And that's the whole point of this meme. Okay, now we finally get down to coding. And in all the programming languages, usually the first program you write when learning a new language is called the Hello World program. Just think of it as a new baby being born, and that baby is saying "Hello World," like over here. Usually, it's written as a sanity check for software. Since we are not really dealing with installation now, it isn't as relevant to us. But you just want to check that everything's working fine, and the installation has worked fine. All of your different environmental variables have been configured fine. And this is what officially begins your journey in the world of Python. So, is everyone excited and ready to start coding? Okay, I hope so. All right. So I have links over here with code templates, and all of the solutions are there on slide 39. But please refrain yourself from seeing the solutions right now Give it a go, and I'll be waiting. I'll also be solving the solution with you, and we'll be discussing it. So hopefully that helps. And if you ever want to refer to it later, you can follow the link on slide 39. So let's get started. This is Trinket. I'll just familiarize you with a little bit of what are the different functionalities that are over here. Uh, Here is where you actually write the code. Here is where you see what exactly a program does or the output of your code. This is the play button, which is pretty much for playing or running the program. Um, okay, let's not get into this. This is for sharing. This is for remixing, which basically means you are allowed to make a copy of this template into your own folder. So I'm not currently logged in right now, but if you are logged in, you could remix it and create a copy of this template into your account. All right. So, like I mentioned, this uses Python 2.7 by default. So we have, and all of these are comments, by the way. See, they start with hashtags, which means that it is a comment. And this is more of a command. I know it starts with a hash. It is kind of like a command, but it also tells Trinket that, hey, I want to use Python 3 syntax. So can you please get rid of Python 2.7 and enforce Python 3? Okay, and now there are multiple paths to the program. We'll just take it one by one. So for now, we just want to output hello world. So let's just focus on this part of it and let's see how we write this. All right. So we have a special keyword called print, which allows us to show the output. We'll be using that and we'll just be writing print. See, it's a keyword and it auto completes for you. So let's use that. And the way to use a print statement or a lot of the other keywords, which are called functions, uh, which we'll know what they mean later, is that you use these round brackets. So you start and you end it. And within this, you specify what you want to print. So we are going to print a string which says hello world. Remember, a string is text or just a bunch of letters. And we have to use quotation marks for it. So I'll just use double quotation marks. Be sure to start it and end it. And inside, I'll type hello world. This is it. That's it. Now let's try running the program. That is pressing the button here. And there you go. Hello world. So have you been able to, all of you on at par with me? Were you able to print hello world? Waiting for the chat messages. Okay, I guess all of you might be busy trying to print this. Okay, someone said yes. Yep. Okay, great. Awesome. All right. Is anyone facing any issues? Okay, got a bunch of yeses. Okay, all right. I'm hoping no one is facing any issues. So, congratulations, you just wrote your first Python program. How does it feel? Do you feel as jumpy and excited like this, whatever this is supposed to be? All right. So I'm assuming you were successful with that. Let's go on to the next part of that program, which is we'll change the string, we'll change the output sentence a little, and instead of saying hello world, let's use XYZ, where XYZ is your name. So let's go on to that. So a very simple way to do this would be just to copy paste this, and instead of changing word or writing world, I could just write Rishma and print it, and this would print it too. But this is not exactly a very intelligent or very wise way of doing it. So let's try to make use of the variables and the data types that we learned about. And instead, let's declare a variable name, which actually has name. So we've declared a variable over here, name, which has your name in quotations over here. And let's try to print this. So how would we go about printing this? We'll be writing hello, which is the first part. But again, we don't know what this name could be here. We could change this later. So let's try to access this variable. And the way to do it would be just using the name of the variable, which is name, which actually is a bad name, but I hope you understand. Okay. All right, so now let's try printing this and see what happens. Okay, so this actually is an error with Trinket. This line should actually print the same thing as this line. I don't know why it's not happening, but I could show it to you in my terminal. So I'm using Python 3, and if I define name is equal to, let's say, XYZ, and I do print hello, comma, name, it prints just fine over here. So I have told Trinket about this. Hopefully they'll correct it soon. But yep, right. As someone mentioned on the chat, if this bothers you too much, you could use plus, and this would work. Although this is not recommended because I think it's not stated in the official documentation. You're still supposed to use commas. But if it bothers you too much, you can go ahead and use the plus sign. Okay, so is it old syntax? It's kind of an unofficial syntax. I think a lot of other programming languages use the plus operator, which is where it's coming from. But yeah, if you look at the official documentation, they advise us to use the comma. All right, moving on. So I'm hoping all of you were able to print hello and whatever your name is. Let me know if you have any problems. Just write it in the chat. Okay. Now our next topic is input, output, and modules. So you were able to put your name inside the program and you were able to print it. But what if the user is not always going to be you? What if you want to like maybe take this to your friends? Okay, it's a very simple app, but what if you're really excited about Python and you want to be like, hey, I can print your name in Python. Do you want to try this out? And if you take this to like, let's say 10 different friends, it's going to be a little tedious if you keep changing the code itself, keep going back and putting it again and again. So I can't read your screen. Can people see my screen? Yep, I am still sharing it. You should be able to see it. Okay. Uh, All right. So an easy way to do this would be you can just accept the input from the user itself. So you can just take the program to all of your different friends and just tell them, hey, whatever your name is, just give me that as the input and I'll print something out for you. So that is where the input function comes in handy. This is a function. This is also very similar to print. If you notice, there's a round bracket opening and closing over here. So we use this to accept details from a user. You can also use it to accept input from a file. Okay, and yeah, you use it to accept value from the user. And output is what we did right now. We printed it. Okay, few of you are seeing it as blurry. Okay, let me just stop screen sharing and start it again. Okay, I'm going to start screen share again. Is it any better? Can everyone still see the screen fine? Okay, I'm just gonna assume it's fine till someone says otherwise. All right. So an output is what exactly we did right now. We printed it. You could also write it to a file. And a module is basically a package or a bunch of Python files that you use. So let's say if someone in the world has already written some files to do some sort of functionality which you want to use in a program. And instead of rewriting the code or reinventing the wheel, you can just use that entire bunch of files, which is what you would call a module or a package, and you can put that in your program. This allows for reusability of code, and in our next few examples, we'll be seeing how exactly we'll use this. All right. If you have Python installed on your computer, this is just like a nice Easter egg. You can go in and type import anti-gravity. If you're curious, I could show you what it is very quickly. So this import is what we use to actually use a package, and we specify the name of the package or the module, and it basically just opens up this comic, which is an XKD comic. Yep, moving on. Okay, let's go back to our Hello World program and let's try to see if we can, instead of specifying what is the name, if we can take it as an input value from the user. So that's where we would go. Okay, so now instead of specifying the value here itself, what we would do is we would use the keyword input, which allows us to take the input from the user. And you need to tell the user something, right? That, hey, please enter something or please enter your name. So inside that, we will write the message that needs to be shown to the user. We'll write enter your name. So let's just run this. And you can see this blinking cursor, which basically tells the user that it's waiting for something to happen on your end for you to enter something. And I can type in, and obviously nothing happens because we still haven't written the print statement yet. So let's go ahead and write that. Again, it's very similar. It's exactly like you wrote it the time before this. Hello, and here's the name. And let's print this again. And instead of Grishma, I'm gonna say XYZ. Yep, again, obviously you see this. So if this bothers you too much, let's use the plus sign and so yeah, you can ask all of your friends to input the name and it would still print whatever they put in as the input. So this is really handy because sometimes you have programs where you're waiting for an input from the user, or you can even have situations where the way the program works or the functionality of the program is dependent on what exactly the user inputs, which is where it's really helpful. All right. So moving on. Okay, now we're coming to operators. So we've already learned about variables. We've already learned about data types, which is all great. But we're still lacking something, which is operators. So operators are nothing but they are certain constructs that you use to help perform functions. Now, for a very basic example would be if I say 1 plus 1. So that plus in the expression is what you would call an operator. It's actually basically the same as what it means in mathematics. And we use operators and variables to form expressions. So let's try simplifying this. Okay, do all of you like pasta? I hope so. So let's say we have the pasta over here. So think of an expression as pasta. Okay, that's your entire thing, that's your entire construct. And think of the sauce as the operators and think of the spaghetti and the veggies as variables. So if your expression is 1 plus 1, that is the entire expression. The both the ones would be your variables, or in this case the spaghetti and the veggies, and you need the plus operator to bind those two together, right? Which is what the pasta sauce would be. And that's how this is an entire expression for you. There are a lot of different types of operators available. The basic ones are addition, subtraction, multiplication, division. There's a special thing in programming known as modulus operator, which tells you what the remainder is. So instead of getting the quotient on division, you get the remainder. Exponent, flow division, equal to, not equal to, less than, greater than, bunch of other different operators. So there's arithmetic, there's comparison, and then there's assignment, and there's bitwise operator. So we'll cover this a little later, and all of this is not very pertinent to what we're doing today, so feel free to read about it later on. But let's go ahead and go to another trinket program and see what exactly happens. How do we use operators? So let's go ahead and declare two numbers. uh, like I said, 49% of the programmers thought that you coming up with variable names is kind of the hardest part. So I'm just going to keep it simple. I'm just going to say num1. Um, let's call it 4. And let's say num2, which is 6. So just go ahead and write two different numbers. And if anyone just join, this is the link. It's goo.gl/od89 capital NR. That is the link to my slides. So, okay, all right. Hopefully, you've defined two numbers for you. Now, let's perform a very simple arithmetic operation, that's addition. So, let's call this as sum. And we use the plus operator. So over here, num1 and num2 are my variables, plus is the operator, and this entire thing is the expression. And let's go ahead and print that. So since now we know how to print a variable, sum is equal to, let's go ahead and print that. Yep, this is annoying. Oh, I did not put that. Let me put that. So, like I mentioned before, we are using this to enforce Python 3, and it works fine here. I don't know why it doesn't work fine for the name example. Just gonna put spaces and make it a little pretty. And you can perform a similar operation with subtraction. Just replace this with a dash or minus, multiplication, for which you use a star or an asterisk, and division. Um, So I mentioned there was an interesting operator over here, modulus. So let's go ahead and try using that. So the remainder is 4. My numbers were 6 and 4, or 4 and 6, and obviously 4 is not divisible by 6, so we get 4 as the remainder. That's where the modulus operator is helpful. All right. Were you able to perform a sum or any other mathematical operation? So I'm going to leave the rest of the sessions as exercise for you. It's fairly simple, so I hope you can do that in a similar fashion. All right, I'm just going to wait for a bit. Were you able to finish this coding exercise? Um, is anyone else having problem reading the code or looking at my screen? It's just that the screen is smaller. Okay, let me see if I can do anything about it. Did this help by any chance? Okay, you know what? I'm gonna open up a new window and see how it's looking for myself. Nope, it's not really. Okay. Nope, it's not really. Okay, it's better in 720. Okay. Try clicking the setting icon at the lower right corner. Okay, yeah. All right, I have increased the size of my browser window, so I'm hoping that helps. But if not, I believe some of the participants suggested to change your stream quality, and that might help. Okay, all right, moving on. So we just performed some different operations and we were able to get the result. These are more operations, assignment, and logical operators. Logical operators are pretty interesting. There's this link to something which really explains it, which is Boolean hair logic. So think of it as two people who have different amounts of facial hair. And if you want to AND it, is basically you want to see what is the where is the overlap or what is the intersection of the facial hair, and you would find it on the ears, and or is what is the union or what is the combination of both of these. And XOR is a different kind of operator which is a little more complex than this, but I would really recommend you to try these different operators for different numbers and see what exactly is the result you'll be getting. All right, very important question. Pineapple on pizza. That is Hawaiian pizza. It's a yay or a nay. Do you like it or not? Okay. Someone said it's good. I guess you are referring to the pizza. All right. So, pineapple on pizza. Does it make you happy or does it make you, oh, disgusting? Whoever thought of that? That's such a terrible idea. Okay. Um, all right. Okay. Sometimes. Can someone please put in the link of the slides? Or actually, let me just put it in. Shreyas, I just sent in the link for the slides. Okay, so now what we're going to do is we're going to use operators to find out something about pineapple and pizza. All right, so let's go ahead and declare two variables. Over here, we'll be using Boolean variables. So let's get an understanding of what exactly are Boolean variables. So let's call this bool underscore one. And if you like pineapple on pizza, put true. And let's define, or else you put false. And if your best friend or your significant other doesn't like it, you put false or true. So now, if we want to find out that at least one person likes pineapple on pizza, we use the or operator. Let's see what happens. Yep, at least one likes, even if I make this true also, it will remain the same. But if I make them both false, which means that no one likes it, the result will change to false. So that is an instance of where the or operator comes in handy. Similarly, you can use an and operator to find that if both of them like pineapple on pizza. All right. Were you able to finish this exercise? Okay. Some of you have responded with a yes. All right. So let's go ahead. So we came to see where operators were useful. So now we know about variables, we know about data types, and we know about operators. So let's learn the next component that's slightly more advanced than what we have learned so far. It's called a control flow, or it basically tells you how the program should run. Like I mentioned before, that it is possible that the way a program functions could depend on the input. And if you do want some sort of decision to be made in the program, then you would use a control flow. So again, we have three keywords called if, elif, and else, which are reserved words. If you remember, those are keywords. And those are the ones that act as conditional statements, or statements on which you would make a decision, or how you would alter the functioning or the working of a program depending on certain input. So a very simple example would be you use the keyword if, and then you specify a condition. So the condition could also be like if likes pineapple on pizza, or if bool underscore one is true, then you take a certain action. Very simple example: if sleepy, go to sleep. But what if you want it to be a little more complex? That, okay, if you're sleepy, I go to sleep, but if I'm not sleepy, what exactly do I do? Which is where the else statement comes in handy. So if sleepy, go to sleep, else stay awake. Very simple. So it just checks for one particular condition, that if you're sleepy, you go to sleep. Otherwise, just stay awake. But what if you want it to be a little more complex? What if you want to combine maybe two conditions, five conditions, 100 conditions? How exactly would you go ahead doing that? So that is where an else if, or the shorter way of that is elif, which is a keyword in Python. That's what you would use. So if sleepy, go to sleep. Else if hungry, eat something. Else, I don't know, practice Python maybe. Okay, something like that. Or if the temperature is below 60 and it's raining, you wear a raincoat. If the temperature is above 60 and it is raining, then you bring an umbrella. Else you can just wear shoes. So as soon as the important thing to remember is that as soon as one condition is met, it does not check for the rest of the conditions, and it just leaves this entire block, leaves this entire part of the code, and goes on to carry on forward with the next instruction. So let's understand how exactly that's happening using one of the most common game examples, rock, paper, scissors. All right, so like you can see over here, we're using the import keyword. This is a slightly different way of writing import statements, which means that from this module or this package, I just want to import something very specific. I don't want the entire package. I just want like a part of the package or a slice of the package. So we're going to use the random module or the random package, and we're going to use the random function in that, which helps us generate random numbers. So let's see how it works. There are four parts to the program. We ask the user for choice, which is rock, paper, or scissors. Then we make the computer pick something randomly, rock, paper, or scissors. And using our if, and else structure, we try to understand who won, the computer or the user. So let's start with this. So since we have to ask the user for something, we will take advantage of the input function, which we used in our old program to accept a name. But over here, we'll be accepting rock, paper, or scissors. So let's see how to do that. Let's say, for instance, player. Just say rock, paper, or scissors. So just for the sake of simplicity, we'll ask the user to enter R, P, or S, which stands for the corresponding element. All right, let's run this and see what happens. Yep, you are asked for rock, paper, or scissors. Well, nothing happens now, obviously, because we haven't written the rest of the logic. Okay, so now we know what the player's input is. Now we can start with trying to randomly find one of those three, which would become the computer's choice. So let's go ahead and specify computer. Let's just say choice is equal to and int. So again, this is kind of like print, but it doesn't do print. It's generating a random number. And what we need to specify within the brackets is that it needs to generate a random number between 1 and n. So over here we have three options. So our n will become 3, which is 1 and 3. Let's go ahead and print that. So right now the computer is just generating a number, but we want it to actually select something, rock, paper, or scissors. So let's go ahead and write a bit of logic using if, and else. And we'll assign one. If it generates one, it chooses rock, that is R, two, paper, three, scissors. So I'm just going to wait a while and give you all a chance to come up with this on your own. Tina, you can go to slide number 39, and I have a Trinket link with all the solutions. So if that might be helpful for you, you can refer to that. Okay, it's very similar to what we saw over here. We'll be using an if keyword if some condition, else if whatever condition, and else. So it'll be in a very similar vein. Okay, did anyone already get it? Okay, let's start. If choice is equal to 1. Okay, so equal to is a special operator. We've already used equal to over here, but equal to is a little different, which is a way of checking if this condition is true. So what you're basically telling the computer over here is that if choice is 1, then you do something specific. So let's go ahead and do that. I will say computer is rock, else if choice equal to 2. Don't forget the indentation is very necessary. There are colons after this, so this would be one block. Looking at the indentation. Oh, what does it tell? Oh, that's interesting. Use if to conditionally execute statements. That's smart, Trinket. And I could write another else if statement here, but I do know that if it's not 1, if it's not 2, it's going to be 3, which is scissors. All right, and now we'll just write a print statement that tells us player versus computer. All right, so let's run this. Let's select rock first, and the computer selected rock as well. So it's rock versus rock, which is a tie. Right now, it's a very simple implementation of this. So we have to figure out the result on our own. But you can definitely extend this further by writing more if else statements or if else blocks and seeing out who won, like programmatically. Let's do it again. Let's again select rock. Uh, well, okay. I'm just going to keep doing it because it's random, so we don't know what happens. Okay, yeah, it changed. So we selected scissors, computer selected paper, and well, yay, we won. All right. Were you able to finish this exercise? So we started out with using the random function from a specific module called random. We asked the player for their input. We made the computers randomly select a number between 1 and 3, which would become the computer's choice. And we're using the 1, 2, and 3 to map it to rock, paper, scissors over here. And then finally, we are printing out what exactly are the choices for both the player and the computer and manually figuring out the winner. All right, waiting for the others, still working on this. Okay, all right. If you have not finished it, don't worry. You still have the code templates, you still have whatever you written saved. So you can always come back to it. All right, we'll go on to the next one. All right, so the next one is again to do with control flow, but what if you would like to repeat a certain set of statements or a certain task? So I don't know if any of you were naughty in school and your teachers punished you and made you like, right, I will not talk in class, or I will not shout in class, I will not throw paper planes in class. And here's a very smart student who basically, instead of writing, I will not throw paper planes in class 500 times, used to loop to actually write it 500 times, which is pretty smart of the kid, right? Yeah. So let's just think if we are the kid and you don't want to write it 500 times manually because there are so many better things to do, right? So let's make use of a for loop over here. There are different types of loops. We'll cover that. So a loops just help you to do things repeatedly, perform tasks repeatedly till a given condition is true, right? If there is no condition or if the condition is true forever, the loop will be going on infinitely. There are two types of loops called for loops and while loops. The structure is a little different, but the way the function is very similar and the result is the same. And if there might be certain conditions where you just want to exit the loop, you don't want to go ahead, you could use the keyword break to exit out of the loop. There could also be certain conditions where you do want to continue it, but you don't want to continue it for that instance. So let's say if I'm running a loop for numbers from 1 to 10 and I want all of them to be printed, but I don't want number 5 to be printed. So what I would do is when it comes to 5, I would tell it to continue. So I'm basically forcing the next iteration before it could even print the number. We'll see more examples of that. Don't worry if it's still a little weak for you. Um, do ensure that the condition you're setting for the loop to exit, for the loop to terminate, does actually become true at some point of time. Otherwise, it will result in an infinite loop. And this is a very important structure because our next topic would be data structures, and we would be using these loops to actually traverse or iterate or move over the data structures. All right, so this is what the syntax for a for loop looks like. You use the keyword for, and then you have a temporary variable in some sort of a list. We'll see more on what exactly a list means, and then it keeps doing something. So it's basically for some condition, you do something. So let's take an example of that. It would be for x. X is our variable over here in range 1 to 5, which basically means that x would start taking a value starting from 1 till 5. So to take the values 1, 2, 3, 4. Just remember, if you're using range 1 to 5, it would go to from 1 till n minus 1. So it wouldn't go till 5, it would just already stop at 4. We're just printing the numbers, print x. So this entire block would print 1, 2, 3, 4. Similarly, we can use a while loop where instead of actually specifying a range or specifying some numbers for the for loop to go through, for the variables to take on the value of, You just give it a condition. While something is true or false, you keep executing statements. For example, while true, I'll keep printing forever. So this statement, this condition is never going to be false because we are specifying that it is true. It's going to remain forever true, 10 years, 20 years, 500 years later also, it's going to remain true. And it's just going to keep printing, I'll keep printing forever, which is what an infinite loop is. So let's see an example of this. Find sum of odd numbers from 1 to 10. Okay, I hope you have the exercise open. And it's very simple. The code is going to be very similar to this, except now we would want to print it to 10. So let's go ahead and do that. Let's use the keyword for, which basically tells the computer that I'm going to start a for loop. Let's use a variable, which is more like a temporary variable or just a variable for our loop to work. So I could name this X, I could name this I could name this pretty much anything I want. In range, this is a special keyword. So like how we used input or print or random for our random integer generation, we use rain, which tells the Python program that, hey, I have this variable I, and I wanted to take a value for all the numbers in this range. So let's do this 1 to 10. And let's again be very careful of the indentation. And we just want to print I since I is the variable it's taking. So right now we'll start small and then we'll build up on this. We're just printing numbers first and then we can print sum. All right. Would this print numbers 1 to 10, or is something missing? Is something wrong with this? Is this going to work as expected? What do you think? Oh yeah, for IN. Okay. Is this going to work now, or is there still some problem? Okay, so let's go ahead and run this. It only print the numbers from 1 to 9. Like I said, it takes up the value from 1 till n minus 1, which would be 9. So if we want to make it print to 10, we have to make this 11. And hey, there you go. There you see 10. Yep, as most of you said, the range needs to go till 11. So that's correct. Okay, I would leave the exercise for you on how you would want to print the sum. You can just, it's actually pretty easy. You can just define a sum or a variable outside the loop as 0. And then you can print within the loop itself. I would say that whatever my previous value of sum was, I want to add I to it. And instead of printing I would print sum. Let's see how this goes. So here it's printing the sum. Initially it was 1, and then 1 plus 2, 3, and then 2 plus, 3, 3 plus 3, 6, and then 6 plus 4, 10, and then so on and so forth. Now, if you just want to print the final sum and not the entire thing, we will just remove this indentation, which means that this is not a part of the for loop anymore. It's not going to keep repeating. It's just going to print it once and for all. And it's 55. All right. So now the next part of this exercise is, what if I don't want the sum of all the numbers, but I just want the sum of the odd numbers? How would I go about it? So the property of odd numbers is that it is not divisible by 2, which means that if you divide it by 2, you would get a remainder that is not 0. And how would we find the remainder of something? We use the modulus operator. Remember the one that looks like a percentage sign? And that would be the modulus operator. So the loop would remain the same, just instead check if the number, or if I currently is divisible by 2 or is modulus 2, and then see if that answer is 0, then you can print it. Otherwise, you can just go ahead. All right. I'm going to leave this exercise to you. We'll go on to the next and the more important part, which is data structures, but I hope you can complete the rest of this exercise on your own. We've already done this. Okay, yeah, this is a joke, which is basically like a guy told his programmer roommate, while you are out, buy bread. And the joke is that the programmer never came home. Can anyone tell me why did the programmer never come home? Take your time. I'll move ahead with the rest of the slides, but if you come up with the answer, let me know in the chat. While you're out, buy bread, and the programmer never came home. Okay. We have guess the number program. Let's see if we have the time for it. Okay, we are not going to solve this right now, but I'll just explain to you what this program is, and hopefully, using everything that you've learned till now, you can put all the concepts together and you can make this program. But it's kind of similar to guess the number game. It's actually just a simulation of guess the number game. Okay, some of you have already given the correct answer. I'm just going to wait a while for others to try thinking about it, and probably towards the end of the session, I'll tell the answer. Okay. So, guess the number. You generate a random number from 1 to 20, and you keep accepting a number as guess from the user till the guess is correct. Okay, so you can go on forever and ever. And how you would go is, yeah, there's a tip over here. You can start with guessing the number just once. So you have that construct working, that part of the code working, and then just try adding in a loop. So the loop would be like till you get the correct number, or till the user's guess is the same as what is the actual number. You'd be using a loop, you'd be using if else statements, you'll be using input. And let me know if you have any problem with this. As I mentioned, the answer is available with the link on slide number 39. So you can get the answers, but I would definitely recommend you to try it out once on your own and just refer to it if you can't get the answer. All right, continuing forward. And this would probably be the last topic we are covering. I will see if I can give you a brief overview of functions and classes later on. But if not, this is the last topic. The most important thing in a program, also the most important thing for programming interviews, is data structures and algorithms. So, what exactly do data structures mean? It's just a set of things, it's a collection of things, it's a certain way values are written inside the program and how you keep accessing them. So, there are very different types of data structures. Uh, the main types in Python are list, set, tuples, and dictionaries, and we'll see what exactly each of them mean now. So starting with a very basic one is a list. Very common real life example of this is your shopping list. Okay, it's pretty much a list. A list is a list, right? Okay, but it's a group of things that are together. Let's think of it as an ordered collection of items. So when you have a grocery list or shopping list, you have like first item, second item, third item, right? And grades could also be a list, maths, science, history, civics, whatever. Colors could also be a list. So pretty much anything can be a list as long as it's an ordered collection. The way to access list is using something known as an index. An index denotes the position of an element in the list. So in Python, as in many other programming languages, things don't start from one, they actually start from zero. So even in lists, your index or something that denotes the position would start from zero. So your first element would be at the zeroth index, or your second element would be at the first index, and so on and so forth. Okay, so let's look at an example of a list. Let's say this is my list this is my list called resume. You define it just the same way as how you would define on any other variable, except you are using these square brackets. So these square brackets are what tells the program that, hey, I'm going to define a list right now, and these are my elements. This is a list with strings in it or with text in it, and that's where I've used these quotation marks. You can even use double quotation marks over here, it doesn't matter. So now, if this is my list where my list is called resume and the elements in my list are C and Python, how would I go about checking if a particular element is in a list or not? You use the in operator. So we already used the in operator in the for loop when we did for I in range. So an in operator just checks if this particular element belongs to a set, belongs to a collection or not. So if you type this print Python in resume, it's going to print true because yes, Python is an element in this list. What are the other things that you could do with lists? You could append to the list, you can add to the list, you could delete from the list, and let's see how that happens. So to add to the list, you use the keyword append. So it would be the list name or the variable name dot append. And within brackets, you specify what is it that you want to append to the list. So let's say I want to append Java. And now if I print the list again, it would give me C and Python as well as Java, which was a recently added element. How do we access elements using index or indices? So if I want to go to the first element, I would say resume of using square brackets 1. That would give me Python. That's actually not first, that is second. So I'll just change this. Or I think I meant it as first index. Yeah. And last is I could just use 0, 1, 2. I could print resume of 2. Or Python has this interesting thing where you can use negative numbers. So negative numbers are nothing but indexes starting from the back of the list, from the end of the list. So it would print the last element. So you start from here, and this is what it is, Java. Other things that you can do with the list are you could delete, you could remove, you can pop. Pop would, so let's say if I were to apply pop on this list resume and it would only take 0, then what gets removed is C. So popping is just removing the topmost element in the list or the 0th index element in the list. And if after removing it, I want to check the length of the resume, it would be 2 because we've already removed C. So what remains is just Python and Java. So this is the special keyword that you use to find out the length of a list. Don't worry about it. We'll go into examples, but just kind of grasp the concept of what a list is, how it is defined, in Python using the square brackets and what are the different operations that you can do with it. All right, very similar to list, but a little different is what is called a set. It's just like a mathematical set. You have a collection of items, but it's not ordered. So lists were ordered, sets not it's not ordered. And what set has it? It only has unique elements. So pretty much like a mathematical set. Let's see how do we define a set. You use the set keyword. Let's say if my set name or variable name is colors, I would use the keyword set and within brackets in a list, see these square brackets over here, I would specify red, blue, and orange. Then if I want to check how many colors or what is the length of my list, I would use the len operator, very similar to how we used over here for a list. And then I would give it so length of colors, which is the name of my set. And this would print 3. Similar to list, the in operator is valid over here if you want to check for the existence of an element in the set, or if you want to check for a membership, same thing. You would say print red, the element in colors, the name of the set. So yes, red is available over here. It would print true. If you say print green in colors, so green is nowhere over here in the set, it would print false. The interesting thing about set is that you can use it to perform 2 additional tasks, which are why square brackets for lists? It's just the syntax of the language. Yeah, so coming back to sets, there are 2 additional functions, which are intersections and unions. Again, they mean exactly the same as what they would mean in mathematics. Intersection is the overlap, and union is the combination of both the sets. So let's go ahead and say if there is one more set called fruits, and this set has only one element called orange. What will be the intersection of colors and fruits? So we want to find out what element is there both in colors and in fruits. So it would be fruits dot intersection colors. This could also be colors dot intersection fruits. Either way, the order doesn't really matter. And what this would print is orange because orange is present here and orange is present here. Similarly, if you were to perform a union on these sets, you would do fruits dot union of colors. Again, the order doesn't matter over here. And this would give you all the different elements that are present in the set, which would be red, blue, and orange. Since orange is repetitive, like I said, a set would only have unique elements, so it wouldn't give you red, blue, orange, orange. It would just give you red, blue, orange. But if this was a list, you could have multiple values, multiple elements for the same value. Okay, and again, like list, you can add elements with, you can use add and update to add elements. To delete elements, you can use pop, remove, and discard. And we'll see how all of that happens in our next exercise. So go on to this exercise, which is our quiz app. And we're going to do something a little more complex, but hopefully a little more fun. And we're going to try to simulate a quiz application using things that we have learned till now. So there are already some things that are present. I have declared a few variables, a few lists for you to use. And let's go ahead and see how that works. All right, so I hope everyone's on this page. So as you can see over here, statements is a list. We're using square brackets over here. That means it has a list with 5 sentences. These are quotation marks or strings or text. And the commas separate the different elements. And I just have 5 sentences over here that are just statements. So basically, we are simulating a true false quiz. It's kind of like the user needs to tell what is true, what is false. Okay. These are the answers which have true or false values, which are our, yeah, which are also strings over here. Yep. Okay. Very first task, let's try to find out how many true or false statements are there, or how many numbers are there in this. How many elements are there in this list? Let's go back and see. For lists, we use len. That's our operator. Let's go ahead and put list in is len of statements. And then I'll just go ahead and print number of true or false statements is all right. So let's see what this does. What happened over here? It's not taking slash bin 3. Huh, that's weird. Okay. Yep. So it needs to be the very first thing in the program, the Python 3 enforcing. And were all of you able to do that? Okay. Let's go on to the next thing. Okay, so now we know what the length of the list is or how many statements are there. But what if I would want to print the unique ones? So if you notice closely, the first and the fourth sentence is exactly the same. So instead of printing all the elements or the number of all the elements, I just want to print the number of unique elements or the unique true or false statements in the list, which is where a set comes in handy. Like I mentioned before, a set only takes up unique values, so we can just use that. So let's go ahead and define statement set is to convert a list into set, just use the set keyword and specify the name of the list inside it. This gives us a set of statements for the statement set. And so if you print the length of the set, you should get 4 over here. Yep, we got 4 over here. But what we want to do is we want to find the unique true and false statements. So this is where we start iterating or moving over the different elements present in our structure, in our data structure, and we want to print each of those, the unique ones. So let's see how we can do that. Remember, we used loops to iterate, so we're going to use a for loop to iterate over a data structure. So let's just say for x in statement set. I just want the unique ones. I don't want the list. So for the unique ones, I'll just go to the set, statement set. So I'm going to iterate over that. And very simple, I'm just going to print x. That's it. This should give us what we want. Yep. To print something, use input. You can see none of these are repetitive. And what was repetitive, the fourth sentence has been eliminated since it's not present in the set anymore. Were you able to do that? Just gonna wait for a while. Okay, a few of you were able to do that. Okay, Now let's start using some operations on the lists itself. So let's go to statements and not statement set. Statements is our list and statement set is our set. Let's try to remove repeated statement from the list without using a set. Okay, let's see how that happens. So that means I'm going to update my list. I'm going to say statements. And what am I going to do is I'm going to do something which is called slicing a list, which is pretty much how you would slice bread. I think some people don't like the upper crusty part of the bread and they just slice it off and just chuck it. So we're going to do something similar. We're going to slice a list. And how do we do that? Is I specify it like this. So I'm specifying the index over here or the indices from where to where I want to slice. And I want to slice this one off. So this is the start of my slicing and this is going to remain blank, which means I want all of the elements later to be there, or I want the slicing to go to the end of the list. Let me print out the statement and then you'll be able to see what exactly happens. So you can see that it's not repetitive anymore. So what I did was I removed this since this was repetitive. So I'm manually seeing that yes, my first and my fourth sentences are the same. So instead of having my list from here to here, I'm just going to remove this part. And now my list is going to be from here to here, which is exactly what you see. So this is called slicing a list. You can change the index. You can see how exactly the output differs. Additionally, there's another way to remove it. So let's say if I don't want to remove this occurrence, but I want to remove the second or the last occurrence of the statement, how would I do it? So instead, I can just use the keyword del, which is for deleting statements. And remember, we talked about negative indexes, which means that you access the list from the end, from the behind, instead of from the front. So, so this would become index, this would become the first element, and this would become the second element. So I'm going to say -2 since it's the second element from the back that I want to delete. Let's run this. And you can see instead now this occurrence is there, but this occurrence is not there anymore since we've already deleted it. So these are some ways to delete something from the list. You can use whatever you want to, however you wish. And you can also use pop to remove an element, which is just statements.pop. You can try that on your own. Now, let's try to add a statement to the list. Let's see what happens. So think of your favorite fact or non-fact till now, since we are keeping everything in the list relevant to what we are doing. So I'm going to say that lists can be sliced. And I'm hoping you know the answer because we just talked about it. And then let's go ahead and append that. And let's print us new list again. So yep, list can be sliced is now at the end of the list. We were able to append it. An alternative to appending is using insert. So if I don't want to insert it at this position, I want to insert it at a very particular position. I don't want to append. So append is used to insert it at the end of the list, and insert is used to insert it at a very specific position. So if you want to insert it at a very specific position, let's say at the start of it, you can just say statements dot insert at 0th position, my new statement. Now you can see list can be sliced this over here. All right. There's another interesting thing that you could do is you can also sort lists. And there are two ways you can do this. Is you can use sorted, which is temporary sort. So just if you want to print a sorted function but not actually sort it internally, then you use sorted. And if you do want a permanent sort to happen, you use sort. So it's a very subtle difference over there. So let's just do it permanent sort. So let's say statements dot sort, and let's print statements and see. It starts with A, C, L, P, T. So it's in alphabetical order now. All right. Were you able to do that? Sort the list. Okay. Should I wait some more? Let me know in the chat. Okay. So I'll just leave this for now. And if you're not done, you can always come back to it. Let's go to the next one. So we have seen lists, we have seen sets, and now let's go to tuples, which are another interesting data structure. It's similar to list, but it cannot be modified. So how we were able to add or remove from lists, we will not be able to do the same with tuples. It's usually good for storing information that shouldn't be changed. For example, you want to say the length, width, and height of a certain object, which wouldn't change. That would be a good example of it. It is represented using our normal round brackets. Again, similar to lists and set, you use in keyword to check for membership, and you use a for loop similar to list and set to iterate over the elements. Slicing indexing is the same as lists. The only thing is that you cannot delete an element. If you want to get rid of something, you need to delete the entire tuple and then come back and write new one. Okay, so over here we have dimensions, which is an example of a tuple. The values are 500, 300, and 100, which are the elements of the tuple. Okay, why is this? This should be okay. Let's one sec. Let's try this. Yeah, so this is a mistake on my part. The length should be 3. I can't edit it because I'm in incognito. But yeah, I'm sorry. That should be 3 because we have 3 elements. Again, you can use in operator. So if 500 is in dimensions, it's correct. If let's say it's like 1000 in dimensions, it would give false. You iterate using a for loop for dim in dimensions, and you print the elements very similar to how we went over a set. And you can use slicing, that is one off, similar to how we used slicing in a list. So it would remove this 500 and it would give only 300 and 100. If you want to access a particular element, again, similar to a list, use an index and you can access dimensions of 0, which is 500. And another interesting thing is that you can use the max operator over here. So if you want to find out what is the maximum of all of these, you can do max of dimensions and it will tell you 500 since that is the greatest value over here. All right, and similarly, if you want to delete a tuple, you just use the delete keyword, del keyword, and just delete the entire thing. All right. One of the most commonly used and very interesting handy data structures is a dictionary, which is nothing but it's an unordered key value storage structure. What does this mean? It means that you would have the name of a property, which would be a key, and you would have a value for the property, which is a value. If you're familiar with JSONs or properties files, it would look something similar like this. It's basically a dictionary. Every key has to be unique, so the name of the property has to be unique. The way you create a dictionary is using the keyword dict. You use the key to retrieve the value. We'll see how that happens over here in this example, and you iterate using a for loop, very similar to all the previous data structures that we have seen. You can use the update function to add something new to the dictionary or to change something in the dictionary, and you use the delete del keyword to remove a key completely. So let's look at an example of a dictionary over here. We have the dictionary computer, where we have brand, Mac, and brand and year are the keys, and Mac and 2016 are the values. And you noticed over here that the values, one is a string and one is a number, or one is an int. So that's completely okay. And if I wanted to access a specific value, so I would just say print computer of brand. That is, I give the dictionary name and then I put the key name, and that would give me the value Mac. Similarly, if I want to add something, I could just go ahead and directly say dictionary of, define a new key over here with a new value. Or else I could even, I think you can even use the update keyword for it. If you want to modify it, you again access it using the key. So pretty much you access the values using the keys. It's kind of like they're attached, they're a pair together. If I want to delete this pair, I can use the del keyword. So if I delete the year, at the end, the dictionary would just have brand and screen size. Okay, let's go back to our quiz application and let's apply something we learned about dictionaries over here. So instead of having two different lists that tells us what are the statements and what are the answers, why don't we map it together? The question would be the key and the answer true or false would be the value. So there's some sort of association maintained. And let's see how we can use that. So now let's go ahead and add a pair of statement answer to the dictionary using update. So let's do quiz, which is my dictionary name dot update. And I would have to use curly braces over here with a colon, where the first part of my colon, the first half before the colon would be my key, which is in this case a statement or a sentence. Let's say, for instance, thesaurus is a data structure in Python. And I'm hoping you all know that the answer is false. It's a dictionary. So let's just go ahead and do that. Oh yeah, I'm sorry. Oh yeah, we can do that. No, let this be. Okay. So now you see over here, thesaurus is a data structure in Python. False, this new key value pair has been added to the dictionary. Now let's do one thing. Let's try to create a list of just the keys in the dictionary. So just these statements, these sentences, and let's shuffle it and see what happens. So statements is equal to, we are going to change the value of statements over here. We're going to make a list using the list operator. And we're going to give quiz, but we don't want the entire dictionary. We just want the keys. So the way you access just the keys is dictionary.keys, which in our case is quiz.keys. And we are using the random module or random package. And in that, we're using shuffle, which actually helps us shuffle all the keys. So the reason we're doing this is that we don't want our user or our player to always keep getting questions in the same order, the sentences in the same order. We want to keep switching things up a bit and seeing what happens. All right. So let's go ahead and do that. And also, while we're at it, let's find out what's the length of our dictionary. Hmm, what happened? Oh, yeah, sorry. So you can see it printed that at 6 because we added a new key value pair. All right. So now this is where the bulk of the logic or how we're actually simulating the quiz application comes into play. What we want to do is we're going to use a for loop to print the questions or to print the statements and basically tell the user, specify an answer. Do you think this is true? Do you think this is false? And after that, let the user know if the user was correct or not. So how do we go ahead and do that? Now, since we need to iterate over this, we need to know how many elements there are in the dictionary, which we already know. That's n. So let's go ahead and specify a for loop for num in range n. This is also a shorter way of specifying 1 to n. And let's say my correct answer is quiz of statements of num. Okay, so this looks a little complex. Let's try to go from inwards. So num is basically 1 to 5. That would be one of our numbers for the current iteration or the current for loop instance. And what we're doing is we're referring statements. So we have statements over here, which are the list of the quiz keys, if you remember. And we're saying that, hey, I want the first element in that list or the fourth element. So since it's all shuffled, we have shuffled it over here, the order is not going to be maintained. And for that, we want the correct answer to be quiz. Okay, so let me just show this to you in print. Print the correct answer. Okay, let's print. Okay, let's just go ahead and complete this and see. So what this does, it finds out what is the current sentence that you're showing to the user, and it basically goes into the dictionary and finds that, hey, this is the sentence I'm showing to the user, so what is the correct answer for this? All right, so and let's print statements of num. This is what we're actually showing to the user or the particular sentence. And then we tell the user that, hey, you have to give an answer. So like we've previously used our input function, starts them as a true or false. And then you can print the user answer. You can print the correct answer. And if both of them match, again, we're using our if else statement structure that we learned before. The double equal to is for ensuring equality. So if they are both equal, then you print correct, yay. Or else be very careful of the indentation over here. You print wrong, go. Okay, so let's remove this for now. Oops. All right, be very careful of the indentation. Everything should be a tab or a space indented from here. And let's see what happens. Let's run this and okay, let me see if I can clear out everything else. This is terrible. So now we can see it in a better way, hopefully. Okay, we're still printing something. What are we printing? Okay, so like you can see that we have shuffled the order for our statement, so it's going to come in some random order. All right, so comments are written using hashtags or hashes. That is true, but I'm just going to say false to see what's happening. And I specified false, but the correct answer was true, and I was wrong. So thesaurus is the data structure in Python. Is that true or false? I would say that's false. And both of these, the user answer as well as the correct answer is false. So they match. You say correct. Python is not case sensitive. I would say it's true, which means I'm wrong because it is actually case sensitive. Set has unique elements. That is true, which means I'm correct. And lists can be sliced since we just saw it. It's true. And finally, to print something, do we use input? No. We use input to take in something from the user, and we use print to actually output something. And that's where our quiz ends. If you start another iteration of it, you would see that the order doesn't remain constant, it changes. So were you able to complete that? Any questions about it? Well, the key, and it's just called a key value pair, or the entire structure is called a dictionary. That's pretty much what you would call it. What's the left side? Yeah, it's a key. The left side would be key, and the right side would be the value. All right, we have 2 minutes left, so I'm just gonna. All right, a few of you have already completed it. So feel free to go ahead and change the statements, change this. You can even use it for something that's not true or false, but true or false was the basic, simplest way to start off. That's why I chose that. Okay, quite a few of you have been able to get it, so that's great. If not, feel free to refer to the answers. The link is on slide 39. We have 2 minutes left, so I'll just quickly wind up. As expected, I was not able to complete functions in classes, but that's okay. That's a little more advanced. Functions are just a block of statements that you can reuse again and again. That's basically for reusing code. You can read about it later. There are some resources towards the end of the slide. Uh, yeah, so you do use the curly braces for dictionary. That's correct. No, you've got it the other way around. You use square for list and you use round for sets. Okay, functions can call different functions. Feel free to go through this. There's a sample function, sample program given a function. Classes, again, is a tenet of object-oriented programming. If you're familiar with other programming languages like Java or C++, you know what I'm talking about. There's this very cool Pong game. It's an assignment also, which I really hope you complete it. I'm just going to take a quick moment to show you what the end game looks like. It's just a simulation of Pong, and we are trying to use functions in this, different functions in this, and it's pretty cool. It's actually one of my first projects ever in Python, and that's how I started learning Python, which is pretty cool. And it's a fun way to show off your Python skills to your friends and family. Okay, I'm going to stop this now because else I'm just going to keep playing this. But all right, moving on. Okay, it's 12. So there are many other applications of Python in programming and web application and whatnot. So feel free to go through these links. These are the resources. This is my favorite resource. It's a huge compilation of a cheat sheet which tells you about all different data structures, all different functions you can use. And this is the link to all of the answers in Trinket. They're all one file. I might have them as separate files later on, but it's all going to be over here. There's a feedback form. If you could fill it out, it should just take like maybe a couple of minutes. If you could fill that out and give me and PyLady some feedback, that would be great. If you're based in San Francisco, I keep conducting these lessons at the main branch of the San Francisco Public Library. So if you want something a little more in person or, to help and debug, feel free to come at one of those sessions. There's a 15% discount on Trinket, which is using this PyLadies code. It's free to use, but if you want some more advanced features, you can go ahead and purchase something. And if you have any questions, that's my website. You have all the links to contact me over there using Twitter, LinkedIn, and what have you. That's it. Thank you so much for taking out time, 2 hours of your precious, valuable time. I hope you had as much fun as I did. So that's it. Keep calm and keep coding in Python. Thank you so much. All right. Thank you.